Hello, everyone. Thank you so much for joining us at the Single Cell Biology eSymposia. My name is Kiki Spur, and I'll be facilitating this career roundtable today. Mentoring the next generation of research leaders such as yourself is a key aspect of Keystone Symposia's mission, and we're delighted to continue this tradition today in a new digital format. So a few reminders before we start. For the first 30 minutes, I ask that you keep your cameras and microphones off. We'll have our panelists introduce themselves and talk a little bit about their career path, as well as a few questions I will be asking them. After that, please feel free to submit your questions on the Zoom chat. You will be able to then ask your question when I select it, and I'll have you turn on your camera and ask it directly to the panelists. You will also introduce yourself as well as where you are, both in your institute as well as your career path. And then finally, we will introduce our panelists now. So today we have Arjun Raj from the University of Pennsylvania, Aaron Streets from the University of California, Berkeley, and Vale Jarvis from our own Keystone Symposia. So panelists, if you could turn on your cameras and your mics and join me on stage. Great.
Hello.
Hello.
Thank you all so much for joining us. It's always a pleasure to connect, even if it's in an interesting virtual platform. So I'd like each of you to just give us a brief introduction about how your career has gone thus far and some turning points and decisions that you made along the way. Should we start with our home Vale Jarvis, Symposia's CSO?
Great. Hi, everyone. So my training, my graduate work was in biochemistry and biophysics, and I went on to do a postdoc in molecular virology, mechanisms of recombination and in RNA viruses. And when I was getting close to finishing my postdoc, that was kind of one of the first big career transition points, was deciding, do I want to go into academics or industry? And my academic experiences up until that point had been pretty basic research focused, mechanistic biochemistry. And I felt I kind of gravitated at that point toward wanting to do something that I saw as a little bit more applied, see if I could use those skills to work in the biotech industry and try and develop therapeutics that would benefit human health. So I ended up, my first job in industry was at a protein therapeutics company focused on inflammatory diseases. So I didn't know much about inflammation, but I knew a lot of protein biochemistry. So that's kind of how I got started on that. That company ended up, their phase 3 clinical trial didn't meet its endpoint. So even though that wasn't directly affecting the program that I was on, it kind of affected the company across the board. A lot of changes, a lot of scaling back of discovery research, which is what I was doing. And at that point, there was an opportunity. I was working in Boulder, Colorado at the time, and Tom Check, who was one of the faculty members there who had received the Nobel Prize in chemistry for his discovery of ribozymes, had just formed a company. And I got in on the ground floor as one of the early scientists at Ribozyme Pharmaceuticals. And that exposed me to some amazing science. I was there for about 6 years. Unfortunately, it turned out that the hammerhead ribozyme motif that we were working on wasn't particularly potent in mammalian cells. We thought it probably had to do with low magnesium levels in the cells. But in any case, eventually for scientific reasons, the company started shifting more toward antisense. They were one of the companies that eventually shifted toward RNAi. They changed their name eventually to siRNA, siRNA. But in the meantime, I was involved in a spinoff that was focused on antisense applications to look at functional genomics. The human genome had recently, the sequence had been determined, and there were a lot of express sequence tags with unknown function, and we had a good technology to address that. So I was with that spinoff for a while, but that ended up being headquartered in Germany. That had to do with venture capital funding opportunities in Germany. And so the writing was on the wall that the scientists in the US probably needed to find something else to do. So at that point, I had my first experience as an entrepreneur, starting my own company, and played around with being an entrepreneur for a couple of years, but we never really got off the ground with a really strong round of funding. And at some point along the way, I decided I probably needed a job that actually paid a salary again. so at that point, again, kind of serendipity, there was another local company that was working on developing antibiotics against the DNA replication machinery and bacteria. And I had done my graduate work in DNA polymerases. So it was a nice fit, kind of coming back to my scientific roots and in an area, infectious disease, that I had a particular interest and passion for. And I ended up working in antibacterial drug discovery, then mostly small molecule stuff, really for the latter half of my career. That company had a good run, but eventually was bought out. And a group of us that were working on the discovery programs there actually spun out our own startup. I got a lot of experience working on grants and contracts through NIAID, which funded a lot of the work at that company. That company is still going strong. I'm no longer working there full time. I'm consulting for them because an opportunity came along for this chief scientific officer position at Keystone Symposia. And again, kind of serendipity, the opportunity found me, and it just seemed like a really fascinating position and kind of unique. And so I took that opportunity, and I've been with Keystone for about 4 years now.
So lucky to have you, Thale. Thank you for joining us. Shall we go to Aaron?
Sure. Excuse me. My name is Aaron Streets. I'm an assistant professor in the bioengineering department at UC Berkeley. A little quick background. I did my undergraduate studies at UCLA, and I did a double major in physics and in the art department, which UCLA has this great art department. And when I was thinking about graduate school, I had to make the decision, do I want to continue in one direction or the other? And I decided physics. But I took a year off first and traveled a little bit because I'd taken 5 years in undergrad, and I was a little bit burnt out. And then I started my PhD in applied physics at Stanford, and I worked with in Steve Quake's lab, who was affiliated with applied physics, but was in the bioengineering department. And that's sort of how I made a transition from physics to bioengineering, and learned kind of through Steve and through a lot of our colleagues that I developed over the years that was a possible career route. You could never take a biology class in undergrad and potentially still have a little bit of impact just with engineering and physics. And so at the end of my PhD, I wanted to continue to do research, but I also wanted to kind of explore a little bit. And so I found this really cool opportunity to do my postdoctoral work with Yanni Huang at Peking University in Beijing. And so I went there with the Whitaker Fellowship, which is an international fellowship. And I went there with the goal of staying for 2 years and sort of feeling out that opportunity. I ended up staying for 4 years. And it was really a transformative phase in my life, both from a career standpoint and from a personal standpoint. It was during then that I kind of decided, that I realized rather, that not only was I sure that I wanted to be an academic, but I thought that I maybe could, because I think a lot of us for a long time, we think, yeah, I want to do that, but I don't know if I can swing it, or I don't know if I can get a job. And so I started looking for faculty positions, and then ended up at UC Berkeley, which has been fantastic. So that's my background in brief.
Great, thank you, Aaron. And Arjun?
Right. So when I was a little kid, I had this book called My Book About Me, where you write like answers like how many steps up to your bedroom and whatever. And as a little kid, you go through and write in whatever you do. And one of them was, what do you want to do when you grow up? And I wrote truck driver. And then like a couple years later, I went back and revised this book. I think when I was like, I don't know, 6 or 7, and I like crossed it out and wrote scientist, like misspelled, but scientist. No. So I guess from like a pretty young age, I had some desire to be a scientist, probably out of some need to please my parents or who knows what. But I think I was just always really attracted to science, abstract concepts, understanding the world. I should say that it started out very differently than biology. It started out really interested um, in physics and theoretical physics, and so that's where I was really, thought that's what I thought I was going to do. I was like, I don't want to be in lab at all. When I went to college, so I went to college at Berkeley. Worked in a space physics lab, but mostly, I was interested in physics and math, so I did a double major in those. And like my worst grade in all of my time in undergrad was in lab class. So I was like, I hate lab. Never, ever, ever gonna work in a lab. Um, and then I had a sort of a weird year off where I was playing music with some guys in New York, whatever. That didn't go very well. Uh, and I went back to grad school at the Courant Institute, which is NYU's math department. They're really known for applied math. And I was starting there, and I was like, well, what should I do? I wasn't really sure exactly what to do. And my dad was like, you should do biomath. I was like, I don't even know what biomath is, but okay. Um, so I started asking around. There was this, I work with this really wonderful advisor there, Charlie Peskin. Very, he's like a well-known mathematical biologist. Uh, did some molecular, like sort of systems biology kind of work, but mostly not. But he was very open to all kinds of things. So I started working in the math PhD. You have a lot of coursework for the first couple of years and quals, and like it's hardcore. But I remember that summer, I was like, kind of want to keep it real. If I'm going to do this math bio business, I should at least get some sense of what it's like to work in a lab. And so Charlie said, yeah, my son plays tennis with this guy, and his dad like has a lab somewhere you could go where. I was like, all right. So I went and worked in this lab for the summer. The man's name was Fred Kramer, who incidentally, very interestingly, actually also came up with Sanger sequencing around the same time Sanger did. The only thing was he did it on RNA instead of DNA, which is a lot harder because all the secondary stuff. So he published like a few months later. Anyway, very cool guy. And actually through him, I got to know someone who is also a sort of joint PI in this lab, Sanjay Tyagi. And Sanjay and Charlie ended up being my two PIs. So I had a really weird math PhD. I actually worked in this lab. I went there for the summer thinking like, I'll just, be, two left feet, mess up all the experiments and leave and confirm everything. And I went in there and I was just like, I fell in love with the energy of molecular biology. It was just so exciting and interesting. And so I ended up kind of doing this weird joint PhD, but like in this lab, but still in the math department. And that's where I, learned a lot of stuff about science. It was really a pretty cool time for me. Then I did a postdoc in Alexander's lab at Alexander Van Oudenarden's lab at MIT, which was also really cool. I got to see, science done at this like super high level. See all of these, top-notch science. The Boston area is just so dynamic for science. It's really awesome. And then I was applying for jobs right at the time of the financial crisis, which was not the best time to be looking for jobs, but I was very fortunate to get a job at Penn. And so I started there in 2010 and, been sort of running my lab ever since then. I would say that actually the last 10 years of time have been a time of really pretty extreme, like pretty profound intellectual growth for me. I feel like I've grown a lot, like understanding people, understanding science, like really, like I feel like I came in like completely untrained, and it's only in the last few years that I feel like I've kind of developed a sense for biology and understanding what it means to learn something in that line of work. And yeah, it's been a really interesting several years. So anyway, now I'm here.
Great, thank you. And thanks again, all our panelists, for joining us. We're really grateful to have you. So as a reminder, please submit your questions via the chat and I will ask you to ask them. But to start off, I do have a question for all the panelists. What is something you wish someone had told you earlier on that you learned the hard way? And dive in, whoever's ready.
Well, I guess I could start. I'm not sure if it's something that I wish somebody had told me, but maybe that I wished I recognized in myself a little bit along the way. And that is, you know, believing in yourself. And I think I was one of these scientists that, I mean, I was always humble in the face of the complexity of biology, and I clearly knew what I didn't know. And I think, especially I think about that period when I was a postdoc and thinking about career directions and so forth. As I said, I was certainly drawn to, I just want to do something to benefit human health. But I think I also saw myself as a consummate team player, but maybe never a team leader. And surprisingly, along the way, I ended up being in a lot more leadership positions as my career progressed. And I think about, people talk a lot about imposter syndrome, and I think a lot more people than you realize probably put themselves in that category to some degree. To me, it's kind of too strong a word. I never felt like I was an imposter, but I also never felt that maybe I could do as much as I ended up being able to do. And so kind of, if I could impart some advice reflecting back over maybe the last 25 years of my career or so from when I finished my postdoc, is just kind of believe in yourself and be open to the possibilities. If you follow your passions, you know, be honest about what you don't know, but also give yourself credit for what you do know, and don't be afraid to speak up, and, you know, be in the room when discussions are happening. I felt like I ended up surprising myself a lot of times with, you know, really doing more and being able to do more than I ever would have realized was possible. So that's my little bit of advice.
Thank you, Thale. And of course, I can vouch for your leadership skills. So we very much appreciate you. Our other panelists?
I'd like to just echo what Thale said, because it's not so much advice that I wish I took, because it's easier said than done, but I felt like it took me a long time to visualize myself in the next stage of my career. And I think visualization is important. You kind of have to be able to see yourself as a blank, as a scientist, as a professor, as a leader in industry before you can get there. And I think that, I mean, you know, if somebody had told me the advice to visualize yourself, it wouldn't have been so easy. But I feel like you're usually oftentimes, I would say for me, I'm oftentimes the last person who's aware of what I'm potentially capable of.
Yeah, absolutely. Just leaning into working on those sorts of skills.
Yeah, like, I don't know how to do it better, but it's just a real thing.
For me, I think if I were to, well, okay, I think people did give me this advice and I didn't listen. And now if I could go back and tell myself to listen, I would. Is just to chill out a bit more. Like, I think it started out really like 100% on everything, and sometimes it's nice to stop and smell the roses. And I think also one of the things I've realized is, like, you know, the demands of my time have increased, is like things won't necessarily fall apart if they don't have 100% of your attention all the time. And it's pretty exhausting to be that much on. And you can get, maybe, I think there are a lot of situations where you can get, you know, 90% of the job done with maybe 50% of the effort. And realizing that, I think being sort of forced to realize that, makes me kind of wish I had known that earlier. But, you know, the one thing with, I guess, the question of, like, you know, what I would have gone back and done is, like, some of these lessons you just got to learn the hard way. I think there's sort of, no amount of somebody telling me. I think people, did tell me that sometimes it's like no amount of people telling you really gets it across, So
Yeah. Yeah, both listening and taking advice, but also choosing your own path. And I think all three of you mentioned serendipity in some of your career paths. Do you want to elaborate a bit on following serendipity, or perhaps even a time that you didn't and maybe you regret it or think it was the best decision to not follow?
Well, one thing I think is interesting to that point is that usually when we tell the story of our career, it sounds like this intentional, perfect path, however squirrely and jagged it might be. Because when we tell the story in hindsight, we just tell about all the successes, and like even just now, the three of us, we had a couple details, but it was like I did this and then I did this, and not all the million things I didn't do or tried to do and didn't do. And so I don't think anybody has gotten to where they've gotten without a little bit of luck, a little bit of help, a little bit of support, a lot of hard work, of course, but it's if you plan out an exact career path, I can guarantee you it's not going to go that way. So usually when even in panels like this, I suggest, don't try to follow any one path, just sample as many possible paths as possible so that you understand the landscape. And then you'll just kind of, you'll have these sort of decision-making moments and some serendipitous moments along the way.
Yeah.
Yeah, I think almost every transition point that I had, there were multiple options, whether it's, choosing which lab to do a postdoc in, or which company to take a job with, or whatnot. And so that's one of the things that I think you really have to learn to trust your gut. Usually which is going to be the best option for you, and there are different circumstances that are going to dictate each of those choices. But that old thing about you flip a coin and then you see whether it's heads or tails, and you assess whether or not you were disappointed or excited that it came out one way or another when you're making a decision. But yeah, I think follow your passions, follow where the science is exciting. Also being, maybe to Arjun's point a little bit, it's easy with science to just be incredibly intense. You're surrounded by incredibly intense people. And the reality is that you're always going to be able to think of more really interesting experiments to do than you'll have time to do in a lifetime. So being picky about what you focus your attention on, sometimes with science, you end up kind of heading down what turns out to be more of a dead end. And, you know it. And sometimes you're not compelled to keep chasing down that dead end to the very deadest events. You usually have multiple projects that you're thinking of, redirect at that point. You may end up like for me in biotech, especially because I worked in a lot of smaller companies, a lot of times you're very focused on a particular platform technology or a particular therapeutic area. Again, sometimes the science will go incredibly well, and other times, wow, maybe that technology platform, like the ribozyme platform that I mentioned, wasn't really panning out. And that's a point to say, time for a course correction. Maybe I want to focus on something different now.
Yeah, thanks, Phil. And I think there's that old fable of follow your passion and you'll never work a day in your life. But my PI commandeered that to be follow your passion and you'll love working every day of your life. So just pick and choose.
I don't know if either of those are true.
Yeah.
I followed my passion, but it certainly didn't mean reviewing grant applications all day.
Yeah, I think he meant it in a way of you should work on the weekends.
Yeah. Yeah. It's interesting, the role of luck. I mean, it's one of these things that's sort of like unknowable. How much was luck? How much was, something intrinsic? And in a way, is it, do you just get lucky to have drive or passion or interest? I mean, there's a number of reducto ad absurdum sort of arguments you could play in that question. I guess one thing that I just want to dispel for, I think, junior people, that's like kind of I think kind of a dangerous myth that goes around, is that like it's all random, meaning that it doesn't matter what you do, like, it's just who knows who and who gets what and goes into fancy journal XYZ and whatever. And I think that's a really bad way to think. It's not random. Like, I think, if you do hard work, I'm not saying they're not incredibly difficult barriers and biases in science and academia, just like in all of human endeavors, but you do get value by working hard. It's not random. And I think that narrative tends to sort of like devalue hard work and effort and talent. And I just want to dispel that part of, like, yeah, we've all had luck, but I don't think it's just random. So, and there's a lot more to that, but I just wanted to put that out there.
Yeah, I agree with that. Wholeheartedly.
Great, thanks. Well, I think we will start on our questions from the audience. So Juliana, if you could join us on camera and turn on your microphone and ask your question to the panelists.
Hello.
Hello.
I'm embarrassed to participate just like this out of nowhere. So I am from Brazil. I am actually studying molecular and cell biology right now, my master's, and I study with Zika virus. Actually, is the whole cell response with at the proteome level. And I am in the middle of indecision moment. Like, I don't know what to do, because I want to go to study in the US for my PhD, but I also would like to try a job, because sometimes I could make a little bit more money. And I don't know exactly what to do. I have a friend who is from the US that I met when I was living there, because I spent some time there. And he told me that I should try, he's a molecular biologist, and he told me that I should try getting a PhD before a job position, even because the job position could be hard, considering that I am from Brazil and there's all the visa requirements and everything. That's a whole process. So the question I asked was like, what could be the best option for me in this moment? If maybe try a PhD first and then later a job position, or if I should, I don't know, try the job maybe you can get. And what are the researchers feel about Brazilian, especially of course, students, if there is a chance? Oh no, yes, I know a lot of people, no, we don't like, I don't know anything. And if it is easy, I don't know, with the experiences you have, if it's easy to get a job being a foreigner, because I did spend 1.5 years, but I was in an exchange program, like an au pair, so there was nothing to do with my studies right now. And I have no idea how it is to get a job for real in the US, So I have these questions, and I would be glad if you guys could answer me. Thank you.
So I would comment on, because you've been working in infectious diseases, I think that, positive strand RNA virus, in fact, I think that there is particularly good funding for research in that area. Having worked in biotech for most of my career, I would still highly encourage you to think about getting a PhD. Although having some work experience before you go into grad school can really stand you in good stead. I think you can, but you have a master's, so I think you're kind of already there in terms of that amount of experience. So I would encourage graduate school. I would guess it's probably easier to get a job in the US in a graduate program than without a PhD and trying to get a job outside of a graduate program, but I would let my academic colleagues maybe comment on that as well.
I think that we have a lot of international PhD students in our program, and I have a student from Brazil in my lab right now. That's just anecdotal, though. I think that one of the things that we're looking for when we admit people into our PhD program, probably the main thing, is potential to succeed doing research for 5 or 6 or 7 years. And one of the best indicators for that is some sort of record of research experience, either in working through a lab. Usually working through a lab of some sort. In many cases, it's through industry, in an industry-based lab, and the different sort of documents or the different ways that we look, the evidence that we look at of that research experience will be, your ability to write about your research, if you had the opportunity to publish any papers or not, which is not always the case, and also the letter that your research advisor writes for you. So I think it's really important when deciding to do a PhD that you look at what's important about that opportunity. Is one, it demonstrates your aptitude to do a PhD, which is really important for the admissions process. But two, it also gives you an opportunity to see if it's the kind of thing you want to do, because it's quite a commitment. It doesn't mean that you have to know what you want to do a PhD program, because I certainly didn't know what job I wanted in the future when I started a PhD, but I knew that I wanted to continue studying and doing research. And because I had a really great opportunity in undergrad to do that, and I really enjoyed it, and I wanted to sort of expand my horizon. So that's kind of maybe the stepping stones to think about when deciding about doing a PhD in the US.
Thank you.
Yeah, I can't say that I have anything really concretely to add, except just that, PhD is a lot of time and heartache doing research. And so I tend to think that, it's best to really consider, like, do you love research? And if the answer to that is yes, then do a PhD. And if the answer to that is no, then you might still want to do a PhD, but think about it more, because sometimes in those really, dark years, it can be like, why am I doing this?
Great. Thank you so much for joining
Thank
us,
you.
Juliana.
Thank you.
So I'd like to ask Dee Hu to join us, and please ask your question. Perhaps we may have lost connection. So I'll ask this question on behalf. So with exciting advancements in single-cell omics and multi-omics technologies, do you think the future would involve more links between academia and industry? If so, how could this be done? For example, how could a new group leader facilitate these interactions?
So I'll just hop in. Yeah, I mean, I think like it's a very tech-driven field. And there certainly could be more links between academia and industry. I think one of the questions to think about as a scientist is like, what do you want to do? Like, what is it that you want to spend your time doing? So for me, myself, like I've been more recently, like I'm really into kind of like answering some deep fundamental questions. And I feel like academia is a really good place for that. If I wanted to make a product, I feel like, going to industry is the right place for that. And sometimes when people kind of like try and make a product in academia, I don't think that like goes super far or goes really well. So I don't know. I kind of also feel like, time is very limited. So to some extent, it's kind of like you want to choose your lane. My experience with industry and like licensing technologies and so forth is that, it's work to do it. And so, if you don't, like, I think a lot of PIs have their kind of like little vanity startup on the side because everybody else does. And I'm not so sure that that's really for everyone. I mean, it's sort of like maybe just kind of like a midlife crisis, don't have anything better to do. So kind of think that's like the thing to do. I don't know, right? I mean, I also kind of feel like there's, I feel like it's a thing to really think carefully about like what you want to do with your time and how you want to spend it, because I think they're very different things and they go towards different goals, and both of those goals are important. But yeah, I think on some level you have to choose.
Yeah, and maybe I would add that, I mean, certainly the explosion in the technologies and the whole single cell areas, it's one of the reasons, for example, that Keystone Symposia supports an entire conference focused on that topic. And yet, I think it's one of these techniques, much like X-ray crystallography, say 20, 25 years ago, where virtually every lab doing biology is going to end up applying these technologies, whether they're academic or whether they're industry. So if you're working in this space, I think that knowledge is going to stand you in good stead almost no matter what question you're trying to ask in biology. And if you're interested in collaborations between academics and industry, this is a good time to be working in this field. And by this field, I mean biological research broadly, because there are a lot of opportunities to collaborate, whether you're an industry scientist or an academic scientist. And that's one of the things that we try to promote in the networking at our conferences. Make sure that the right people know each other where there's fruitful reasons to collaborate.
Aaron, do you have anything to add?
Oh, I mean, I agree with, it's a really big space. I don't know historically, but I think that it does feel like there's in a lot of areas, especially in single cell, less separation between industry and academia than there used to be, just in terms of you can do really cool research in an industry setting. And there's a lot of crosstalk. There's a lot of, the nucleation of an idea and then like the development of an idea and then the application of that idea kind of jumping back and forth. And that's really exciting. I don't think that there's a roadmap to starting those technologies. I think it's kind of like what Arj was saying. Things work kind of based on what your priorities are and what you're interested in solving. And sometimes there's a nice tool out there that's already commercial. Other times you need to develop a new one and to answer the question that you're looking for. So case by case.
Great. Thank you. And thank you all for joining us. I forgot to remind everyone to turn your cameras back on. So we're glad to see our audience. I'd like to ask Samuel Marsh to join us and ask your question, please.
Yep. Hi, guys. I'm a postdoc. My name is Sam. Kind of following up on some of the ideas of how you focus your time and all the different demands on your time. I'm wondering if you have any tips, either as a group leader or as a PI, for how you manage all of the kind of different buckets of demands on your time. It's something as a postdoc that I already feel between doing science and mentoring, RAs and going to meetings and all these different things. And the demands the number of buckets only increase as you move up the rungs in the ladder. And so kind of, any tips that you had or things that you wish you knew when you were first starting out in a more senior position that you think are helpful for kind of avoiding burnout and managing your time?
I'm actually interested in the answers to this question as well. So
yeah, right.
I don't have a good. Oh yeah, go ahead, Arj. Why don't you start? Yeah.
I spent like a fair amount of time thinking about this, and actually for our like incoming grad students, I've been running this little like skills class where we cover some of these things. So one of the first things to think about are the Eisenhower matrix, it's called, like A task, B task, C task, D task. So it's like really dumb, but basically what's important, what's urgent, and not important, not urgent. And dividing your tasks up that way can be really important. So there's like important, urgent, that's like grant due at 5 p.m. Do that first. Then there are things that are like urgent, not important, like admin wants you to sign XYZ form for like cookie reimbursement or whatever. Like that can be done later, right? Like, yeah, it's just not important. Then there's important but not urgent, and that's kind of like the most interesting one. That's like read up on the literature on some new topic. And the biggest problem is people that's like the B task, and the C task is like urgent, not important. And that's the biggest problem, is people end up swapping these two. So you spend a lot of time filing cookie receipts and not enough time because it kind of makes you feel like you like tick the box, like, oh yeah, I just take care of all these cookie receipts and I finally have the time to really do work. And then you just end up doing that all day long and not actually doing anything real. So that's like one of the biggest things, is just organize what you're doing in that way. I should practice this as much as I preach it. All right. Like it's hard and it takes some amount of effort. I try my best, but you know, nobody's perfect. So don't beat yourself up about it. Other things is like know your cycles. This is another thing I learned in the management course. It's like super useful. Is like most people, like myself, I'm strongly morning person, but most people have kind of like, you know, peak sort of alertness, attentiveness in the like morning at some point. Then you eat lunch and everyone's kind of like, oh, after lunch. And that's like, and then maybe there you have like a second bump in the late afternoon. And then sometimes it depends, obviously variation from person to person. Remember that all the people who want to waste your time also run on the same schedule. So all those emails that you're going to get about cookie reimbursements are all going to show up at the time when you're like maximally alert, right? So you're going to be like, oh, here comes another checklist box that I can like tick off. Like, don't do it. Like, batch process all of those emails later in the day when you're like after lunch. That's the ideal time to do that. So figure out like those like simple things, like being aware of your biorhythms and helping using that to manage your time. I think is like really important. I can give some amount of time management also as like a PI. One of the things that I've done is that I realized that like I felt like I was keep doing the same thing over and over when I was working with people, like teach them like, this is how you make a figure, this is how you do whatever, this is how you write this, how you write that. One of the things I found is doing like worked examples of things to model behavior really helps. So I'll give you an example. Whenever I get a paper to review, I usually review it with the people in my lab. And what I used to do is just say, hey, do you want to review this paper with me? And they would review it and they'd kind of like write up some review. And I was like, oh, thank you. And then I was like, now I have to rewrite this whole thing. So I'd like go back and like rewrite the whole thing the way I liked. And I even gave them like, okay, here's my like blog post on like how to review a paper. And it still wasn't working. And then what I did was I said, okay, let me take like a Google Doc of some reviews that I've already written and just annotate it. Be like, in this sentence, as you can see here, this is what I write about and why. In this paragraph, it's about blah, blah, blah. Here's what I do. And this is like how examples of how I do everything. And like instantly I got reviews that were practically submittable right away, because everybody that you work with is smart. They know what they like know how to do things. They just need to know what behavior you want them to model. And so I found that like worked examples and code, and it's a huge time saver for me. So anyway, those are just like a few tips that I have. But generally I agree there. It's like, please, if you know what to do about this problem, let me know, because like it's pretty bad.
Yeah, thank you for those ideas. Certainly, I need to practice your table idea. I am a master procrastinator who elects to vacuum rather than finish grants. Great.
Yeah, it's hard to know what to add to what Arjun just shared, because those are all like such great pieces of advice. I have a couple more on the very much more simplistic end of the spectrum. One is something that my postdoc advisor shared with me that was a piece of advice that she got from her graduate advisor. She was the sort of person who was so intent, like when she'd get going on something in the lab, she'd pull an all-nighter and then exhaust herself and then not come in for 3 days. And so anyway, the advice was work more than 6 and less than 20 hours each day. It seems like a simple thing, but the idea is really to just pace yourself. And the other piece of advice that I would give people is something that I arrived at when sometimes it's just overwhelming. There's so many different things you have on your mind, tasks that you need to do. What am I going to prioritize? I would find myself almost in a state of paralysis. And I remember at some point, this is pretty early on in my career, just thinking, I just can't even figure out what I need to do. I'm just going to go for a walk. And it was amazing, that half-hour walk. My mind just processed. I came back with an exact priority list of what I was going to do. My experiment was better as a result of having reflected on it outside of the lab. And that just became I tried to make it even just a regular part of every day if I could, just a short walk, give yourself permission to just step back and get all the other inputs, get away from your computer screen, away from the email, bing, bing, bing. So.
Yeah, thank you, Phil. And certainly that's something that you've encouraged the Keystone Symposia staff to do as well. So we're very grateful to have that.
Sometimes there's ice and snow though, so it can be a little tricky.
Arj mentioned something in the last question about there's limited time. And so you really can, it's really important to focus on, what you're good at and also what's really important to you and what you want to do. Like I do way too much service for as an assistant professor. And then I'm constantly like trying to learn how to say no and do all these different exercises everybody tells you. But also I think it's really important. That's one of the reasons why I wanted to be a professor. And so I don't have an answer, but one of the things I'm working on is feeling good about the service that I want to do and not feeling like I need to say no more, but really then highlighting what else is really important. Just like visualizing what's important is part of the exercise, like in deciding for you what are the important things. I'm working on that, but I feel like that's something that you need to do first before you can time manage.
Yeah, that's great. It's something that often is mentioned, but very hard to practice. Okay, so can I have Chi-Yu Shen join us and ask your question?
Hello, everyone. Yes, so I'm a PhD student from Weizmann Institute in Israel. So now I'm at the final year of my PhD, so I'm already starting to looking for postdoc positions. And once you're looking at it, it's come into my mind that there are a lot of big shot labs, but not in a very interactive scientific place. But there are also not quite big shot labs that's in a very scientific interaction places. So I'm just wondering, how would you choose when these two are conflicting with each other? Of course, the best way is to choose both. I mean, in a good lab, in a very good environment, but sometimes you just don't have the luck to choose the both together. So if this conflict, what would you choose?
I would say just one kind of offshoot from that question is that whatever one you choose, I would optimize for happiness for yourself. So, because there's not a right answer to that question. I mean, you could find examples of success in both cases, but one thing that that can help ensure that you'll fail is if you're not happy, if you don't enjoy what you're doing. And so, if you're, that's kind of my main advice. If you're in front of a decision like this and you have which one's better, which one will I enjoy? It seems kind of simple.
Yeah, go ahead.
What he said.
Oh yeah, I mean, I was just gonna say, in terms of the different environments, the really big name labs, I mean, there's no question that, it opens doors to work with a really famous scientist and publish papers with that person and so forth. I do think that some of those labs are so big that, there is sort of the trade-off of, is it really going to be a great environment for you if the lab, you rarely interact with the PI and there are 25 postdocs in the lab or something. However, that's not to say that there can't be great projects and great experience there. It depends on the lab, and I've looked really hard at when you interview, really talk to the people in the lab, also look at the past, like where have people that trained in that lab, where have their careers taken them, and has that been a good training environment? I think, the other type of environment that you describe where you have maybe a slightly less well-known lab, but still hopefully doing, really great, really solid science, but in a really interactive department, is the advantage there could be that you also could be collaborating with other labs in that department and getting exposure broadening your mentor circle, broadening your circle of co-authors, and so forth. So I think that, you know, either one, there is no right answer. Either one can be the right answer.
Thank you.
Thank you. All right. And can we have Sichi join us with your question? I know there's been some chatter on the chat, but we'll circle back in.
Hi, my name is Sichi. I'm a graduate student with Barcoan at Washington University. So my question is for, maybe it's mainly for Aaron and Arjun, that like coming from very theoretical background, applied physics and mathematics, how does that very theoretic like framework of thinking help you to shape your questions? And also like how would you give advice on how to acquire that theoretical skills in a more experimental science or mixed computational biology, that kind of program? Thanks.
Let me think about that a little bit. I mean, for me, it's a lot of it has to do with, I mean, you said theoretical, but I would just say more from like just a physical science and engineering standpoint. That just is kind of the way that I like thinking about. So I would say the shape, it's not an advantage or a disadvantage, but I think instead of thinking about what's, you know, everybody is sort of defined by the collection of their experiences and their goals and their childhood, as Arj said. And for me, what I like about this field is thinking about, you know, how to make ways of solving problems. And that's kind of what drew me to physical sciences initially in physics, was, you know, understanding the system well enough to be able to solve it. And so it's really, for me, that's more of just about how I like thinking about my work. And I don't know if there's an advantage. There's people that are much better at theory than I am. And there's also people that are much better biologists who don't use any theory.
Yeah, I think where it's helped me the most is just like I was writing in the thing, just like sanity checks, just like, does this make any sense? Like, oh, okay, like I expect 2% of cells to do this, but I'm getting 15% of my facts. Like, that doesn't make any sense. So it's not exactly sophisticated, but I think at some level, just kind of like trying to make things give a quantitatively consistent picture. You can find a lot of errors and issues with your analysis. I mean, there's a broader question as to whether why mathematics and mathematical modeling has not been more useful in biology, and you know, that's perhaps for another panel discussion. But yeah, I mean, in general, my feeling is that the mathematics has not been particularly useful in biology, and yeah. Anyway, but that's like a whole other can of worms.
Okay, great, thank you. And I'd like to ask now Sylvia to join us and ask your question, please.
Yeah, hi, I'm Sylvia. I'm a postdoc. I was wondering how you guys decided between sort of the trajectory of becoming a PI and going into industry, or if this was sort of always completely clear to you, or if you were ever at a point where you were sort of considering both options. And I don't mean here like working in a big pharmaceutical company, which is obviously like completely different from being a PI. But yeah, I wondered if you could comment on that.
I was thinking about this because this was a prompt question also. And there's a lot of, I mean, you know, it's easy to say, do you have to decide what you want to do or something like that? But one way to think about it is, at least it was for me, was like, what kind of impact I want to have in my career, or how much impact is an important thing in my life, you know, or whether it's important just to get a good salary and to enjoy my life and you know, to do cool things because I like, you know, so how important is it for you to have impact, and then what kind of impact you want to have? And I think there's a lot of overlaps between industry and academia in a lot of ways with research. But I think one difference is in academia, you have a lot of opportunity to impact people through mentoring and through some of the systems at a university, and you know, so that's one view, but that's kind of one variable maybe that you can think about, teaching, etc.
That's a gotten kind of further along in my career, I kind of view academia much more as like a service position. Like I finally understand that like my purpose is like as a steward of knowledge, right? Like I learned from people. I am learning a couple little extra new things, but mostly I'm passing on the lessons that I've learned to a next generation of scientists to go on and do something else. Like in most companies, you have like star employees, you want to keep them. In academia, we have star employees who want them to go on and do other things, right? So I think that's like a key difference, is that like in academia, we're sort of living in like service of knowledge, service of people, developing our trained workforce for the future. And I kind of feel like in the startup world, like it's like you're trying to make a product, you're trying to really like, you know, it's a different sort of world, I think. Also, you know, like I think there's a lot less writing in like there's a lot more writing in academia, endless writing all day long. So, you know, like I think that might be less. There's also, I think, more of a team focus in startups often, right? Like people are working together to in service of one goal, like all together, whereas it's a little more lone wolf by its nature in academia. Like you kind of work on your own projects, and I mean, you work with people, but it's a bit different in that way. Anyway, but I think to me the biggest thing is that like academia, it's like it's a service thing, like where it has a different goal to it, and I think that's a very fundamental thing. So I would think about like which side of things suit you better.
Yeah, that teamwork theme is really big in industry. If you enjoy being part of a team where, you know, you're all working toward a common goal, that I think you will get a lot of enjoyment out of research in industry. I did hear a really interesting statistic a while back. I think it came from, you know, the NSF tracks all these statistics for the sciences. And roughly 80% of people that earn a PhD in the life sciences in the US end up working not in academic research. And that probably doesn't come as that much of a surprise to any of us, that in that, as Arjun just said, academics, it's, you know, it's this service of training the next generation, and then they go off and do, and there aren't places enough for them in academics, even if they all wanted to stay in academics. But it's more than just that. I think when you go into industry, you might start out basically doing research of a somewhat similar nature to what you might do in an academic lab, but then you get exposed to other aspects of the industry. And for example, you know, clinical development is not something that a lot of us get much exposure to in our graduate work or postdocs, unless you happen to work in an MD PhD's lab, or you are an MD PhD yourself, and then maybe you would have had some involvement already in clinical development. But that's a whole career in and of itself. There's the regulatory sciences. How does the FDA and its counterparts in Europe and Canada and so forth figure out how to determine what steps need to be accomplished to approve a drug or a vaccine? There's intellectual property. How is that protected? What is the strategy there? There's business development. There are specialties in pharmaceutical science that, you know, again, if you have a bioengineering background, you might get into how to formulate drugs, how to make nanomedicines. There's just all kinds of things that you might or might not get exposed to in your academic labs. So it opens up a lot of interesting possibilities. Some people go into industry though and eventually find, you know, I'm really gravitating more back toward an academic path. And the nice thing these days is that it's not a binary choice. It's not like you have to make that choice once at the end of your postdoc and that's it. There are a lot more opportunities to cross back in either direction these days, I think, than there were, you know, 10 or 20 years ago.
Is that really true though? Like maybe maybe the academic people can comment on that part. Like if one would go to a startup for like 2 years or something, and one would not publish a high impact first author paper, presumably. Like, is it really realistic to then apply for a high profile academic job?
I mean, we hired someone in my department who was in venture capital for 2 years, 3 years. And I know someone else, they went from grad school to management consulting for a couple years and came back, had some super high profile paper, got a job offer at, top tier place. Now is working at a startup. Like, all kinds of things happen. So
you would not necessarily have to publish even during that time in
Are people going to scrutinize it? Yeah, but nobody's expecting you to go like publish papers at a startup necessarily. The question is really like, it's funny because I think like, when it comes to like how to get the faculty position, I think like, people want to like, what are all the boxes you need to tick? And the number one is to just like be the best scientist you can, like publish your work as well as you can, and like meaning like do the best quality work you can. And that's really like the only thing you can control. Is there randomness to it to some extent? Yeah, sure. Those are things you can't control. But all these other things that people think they can control, like make sure you have the linear path and you do this and that, actually I think matters less than people think. Like people will look at those things and people might even think that's a reason they didn't get a job or did get a job or whatever. But in the end, like the discussions in the room are typically, or at least largely, about like, does this person do awesome science? And, I'm not saying it's easy to get these jobs, but, I wouldn't put too much weight on like, I need to have like 5 cell papers and never have taken like a weekend off in my entire life. Like that I can tell you is just not true.
Okay, thanks. That was very helpful. Thank you all.
All right, well, thank you everyone. To be cognizant of time, we have run out, but I'd encourage everyone to join the one-on-one chats. So those folks are available for some quick check-ins and some quick questions. And then remember, there's going to be a social hour and networking function at the end of the conference, so you can connect more with other attendees. Thank you all so much for joining us, and we'll see you back in the sessions. Yes, thank you.
Yeah, nice chatting with everyone.
Y'all.
And Arj put his email in the chat, but yeah, you're also welcome to email me as well. I'll put my email in the chat as well.
Yeah, actually, Theo, I don't know, and Kiki, can we set up like a Slack or something? Maybe that would be a
so we do
way to.
So I can set up a new forum. Usually we don't have the Career Roundtable as a forum because we do this and we've already asked you to put your time in here, but I can go ahead and do that if you want to go ahead and answer further questions there.
I don't know if other people are into it, like people got more questions. I'm happy to answer them. It might be better to do it more like so everyone can see.
Yeah, so the forum will see all the answers and stuff. So yeah, just check out this session forums and I'll go ahead and add that right now and you can put further questions and comments in there.
Awesome. Thank you so much.
Great.
Cool.
Thanks everyone.
Bye people.
Yeah.